Hello there, and thank you for tuning in to video number 6. Today we sort out some RF. But first a little catch up. The VFO mode setting enables the user to select either CW, AM, lower sideband or upper sideband, which is outputted via this connector and can be used to switch the BFOs using a simple interface board. Here is the board. It uses a transistor to switch a relay that directs 9 volts generated from the BFO section on the main board to either of the two crystal oscillators. Here is the board fitted and working. This is the wire I spoke about from the VFO board. This is just 12 volts and here is the grey wire that comes from the 9 volt regulator, which is here, and simply either sends it to this one, which is the upper sideband, or this one, which is low sideband BFO. It's as simple as that. So all this does is distribute the 9 volts from there to either here or there. That's it. So like the DC power board that sends 12 volts to the various circuits at the right time, we need an RF board that does the same. So first we need a circuit. So this is the circuit I chose. It uses 4 relays, 2 smaller just single changeovers and then 2 larger double pole changeovers. Signal comes in through the left. This first relay is purely to select between 2 antenna sockets. If you want to put that in your project, I'm only using 1 antenna, so I'm using the normally closed position. I don't energize that relay, but you could perhaps use 1 port for receiving, 1 port for transmitting, for example. If you're using a loop for receiving and a dipole for transmit, that would work nicely. Or perhaps a dipole for 20 meters, dipole for 40 meters, something like that. But I thought I'd include that. It's just something for the future. So the antenna, the signal comes in here. The next relay is purely the receive transmit. In its resting signal, the signal passes through. In transmit, it's diverted, so the transmit goes out through the antennas. The next 2 relays are the larger ones. This first one, in its resting position, the signal goes straight through. If you put 12 volts on it, it's directed through this simple pi attenuator, 10 decibel. Just drops the signal a little bit if it's a little too strong. Next relay is again in its resting position. The signal goes straight out to the receive board. When you put 12 volts on there, it's diverted through this little preamplifier circuit. It's about 20 decibels roughly. I did try some mimic chips and I just couldn't get the things going. They oscillated and all sorts. I'm sure with a little more time and better PCB construction I could have probably got it to work, but for simplicity's sake, and I did want that to be the goal of all this, we went back to this tried and tested circuit. I've included these photos showing the surface mount version of the mimic chip design. I'm sure a double-sided board would have worked, but I spent so much time faffing with copper tape trying to stop it oscillating. I just stopped and went back to the original idea, and for speed I didn't take any pictures, just the finished item. Here's a finished board. You can see there's the 2 antenna sockets. I'm using this one, but there's the other one if you choose to use it. This will go off to the low pass filter and linear board, which is the next project. And here is the receive port that just goes to receive on the exciter board. This transistor's biased quite hard, so it does need a heatsink. And there are some capacitors underneath the board simply because I only had surface mount in stock, so I just popped them on the other side just for speed. I was running late to get this video done at this point. So yeah, there you go. I'll show you the bands are rubbish today, but I will show you some recordings I did from earlier in the week.
This is Mike 0, Charlie, Hotel, Kilo. Name here is Andy, and the 3 would be from the same before. You're up to 5 and 6 at the CFC, and 7 FFI, Mike 0, Charlie, Hotel, Kilo.